Hi students, we are going to continue few problems regarding Young's modulus or elongation in one dimension. So elongation due to its own weight. Let's see the question. A rod of uniform cross section area A and length L has weight W. It is suspended vertically from fixed support. If material of the rod is homogeneous and its modulus of elasticity is Y, then determine the elongation produced by the rod due to its own weight. Okay, there is a rod and it has weight also, the W. So how to get the elongation in this case? When you see previous questions, we discussed few important points. Like this is a previous question which I discussed. We found a tension A and tension in brass and tension in steel we found, and then we try to solve based on it. Okay, similarly this rod itself has mass. If rod itself has mass, we need to do, in this video especially, we are going to do a lot of integrations and some simplifications. Okay, the rod has mass M. Okay, rod has weight W, or assume the mass of the rod is M, total mass, M total, MT. First of all, we should assume at a small distance x there is a small length dx. Okay, how much is the downward weight that is acting? Mass up to x is equal to, so this is a uniform cross section, to mass per unit length, mx by x is equal to total mass by total length, mx is equal to m by l into x. Okay, we got mx value, and the downward force due to mx, the small length dx will elongate a small length of de elongation. The small dx is undergoing a small elongation de. Okay, first de is equal to small elongation is equal to force. How much is the force acting? mx into g, that is the tension at this point. Okay, so T into L by A into Y. Okay, it's not, listen carefully, dE is equal to, tension is equal to m by L into x. L is nothing but, what is the section, small section, dx by area A and y. Okay, dE is equal to integrations on the both sides, elongation delta E is equal to, from where to where, x is starting from 0 and up to the length L. So 0 to L, limits are m by L A y, x dx integration are x square by 2, it becomes m L square by 2 A y into L square gets cancelled. The final answer remains as m L by, it's a mg. G is supposed to be here, T is equal to mx into g, mg ml 2a into y. This is the elongation in the rod. This is a small elongation in the rod. Okay, and the entire rod due to its own weight. Sir, how can we simplify this? If the questions are given due to own weight, what is the weight of the rod? mg. Okay, elongation formula is equal to force into L by area into y. If the rod has its own weight, what is the elongation we got? Elongation is equal to, listen, mg L by 2a into y. How much is, instead of mg, what has come? mg by 2. So in the downward direction mg by 2 is acting, upward direction mg by 2 acting. It's a shortcut, understand? It's not the method. If force is given, if it's due to own weight, you can directly write as E is equal to mg by 2. Now the question can vary. I am varying the question. Okay, I am erasing everything. Now the rod has, there is a rod, uniform rod. A rod has mass m, small m. It is attached to another mass, capital M. How much is the total elongation? Listen carefully. Elongation, two elongations will be there due to own weight, and due to elongation due to mass, external mass. Okay, delta L due to wound weight is equal to mass is how much? M. How much is the force? Mg. How much will be? It's not mg. Mg by 2 L into Ay. Okay, due to mass M, delta L due to mass M is equal to capital Mg L by A into Y. If you want total elongation, delta L is equal to delta LW plus delta L into external. So just add these two, you will get the value of total elongation. Let's go to the other question. Uniform rod of length L and mass M is pulled horizontally on the smooth surface with a force F. Determine the elongation of the rod. So listen carefully. This is a rod, horizontal rod, and it has mass M, length from here to end to end L, force applied is F. Okay, so when the mass, when the rod, if the rod doesn't have any mass, elongation is equal to F into L by A into Y. If the rod doesn't have any mass, but rod has mass now. If the rod has mass, then it's little difficult. We should do integrations. So from force, just get at a distance x. Okay, a small length dx, and elongation in the small length is de. Okay, listen carefully. How much acceleration it is going? F by m. Okay, just before the dx section we should get the force value. Okay, listen carefully. Force F is acting here. How much is the mass here? M by mass in x section is equal to m by L into x. So the tension in the other side, it acts T. M by L into x is the mass. Acceleration in the right direction, tension is equal to F minus T is equal to m by L into x into A. A is equal to F by m. M gets cancelled. So T is equal to F minus x by L into F is equal to T. So T is equal to 1 minus x, sorry. So T is equal to F, you take it as a common factor, 1 minus x by L is the tension in the this part T. Okay, if you draw free body diagram, this section dx section I am drawing. So tension why you draw in the backward direction, if you ask, because it is acting in the backward, little disturbance is there. So because of tension is acting in the backward direction, I am considering this as a two blocks, block 1 and block 2. On block, tension will act in the backward direction like this. On the block 2 of dx, the tension will act in the forward direction T, and the small section is dx. Elongation here, E is equal, dA is equal to, dA is equal to, formula is F. F is nothing but tension into L by A into Y. T is equal to what? F into 1 minus x by L into L, what is the length? Dx, small section, dx by, so area A into Y. Now integrations from where to where the limits start? X is starting from x is equal to 0 to x is equal to capital N. So 0 to L. We can integral d is equal to delta E, elongation, total elongation is equal to delta E is equal to F by A by, so we are doing integration till dx is equal to x, and x minus x by L is nothing but x square by 2 into L, limits are from 0 to L. If we substitute F by Ay into L minus L by 2, which is equal to F into L by 2 into Ay. So this is the total elongation. Total elongation is equal to F into L by 2 Ay. Similar to the previous question, how much force is applied here? F. How much? Which side? One side. So we are going to simplify this again as okay. So generally, if it is massless, if m is equal to 0, elongation would have been F into L by A into Y, because it is massless, elongation will be same as it is like that. But if the mass is present, then the diagram will change, like on the both sides. What is elongation force? F into L by 2A into Y. So we assume F by 2 in this direction, F by 2 in other direction. Total elongation is equal to, so force F by 2 L A Y. Simple. Okay, we'll do remaining questions in the next.